Hey folks, welcome back to another video. And this video is going to be a little different because I wanted to go over a new little tool, if you will, that I picked up, which is really in the realm of the midweek machining video series because it's for the lathe. And this is a tool post grinder. It's a Dumore tool post grinder. I have barely looked at it. It was kind of a really quick thing that I bought this morning down south of me in Northport, Florida, which is about an hour south. I was down two and a half hours south of me, so it was kind of on the way. The Voyager came back and it was here for about another month. I didn't film any of it. It was just an absolute nightmare. The customer and I have come to an agreement, and I dropped it off to him doing the best I can, the absolute best I can on it. And we shall see it no more. So let's move on from there and let's take a look at this Dumore, because when I was on the way back from where the customer lives down 2.5 hours south, I stopped in Northport and picked this up. I'm not even sure what model this is. I took a quick look at it when I picked it up. I got a really good price on it. I have no idea if it's going to fit my lathe properly, but it is a small one, so I'm assuming I'll be able to make it work. Let's see, it's a Dumore 11-011 is the serial number. The catalog number is 11-011. So I guess that's kind of the model number too. But it looks like it's in fairly complete condition. And we're going to go ahead and take it out of the box, take a look at it. You can see the cord is in pretty bad shape. Do not know what year it was made. I don't know if there's any year on this plate or anything we can decode to determine that, but I guess it doesn't matter. It does spin. Well, anyway, let's take it out and we'll take a closer look at it. I tell you what, this other box has got some other stuff in it. Parts of another one. We'll take a look at that here in a minute. I think this thing, yeah, it looks like it's bolted down to a stud that, you said stud, that's made into the box as something to keep it from rattling around. I've always wanted one of these for quite a long time now, one of these tool post grinders. They can come in handy. They can come in handy, significantly, I guess that'd be a way to put it. Here's some belts for it, and the numbers on one of them, which is nice. Megadyne. Sounds like a character from Marvel Comics. Come on out, you. Got some weight to it. Whatever that, oh, this looks like some sort of a chuck, because it's got a thingus. I don't know what it is. So, we obviously need to put a new cord on it. That's in pretty bad shape. Let's take a look at the end. Yeah, so it doesn't have a ground. We will change that. We'll put a 3-pin plug on it and ground to one of these screws or something. We definitely want to ground the case, but I don't know if this is original. It says Belden, so it's I recognize the name. It's an old Belden cord. Well, that's a ground right there, isn't it? We'll do it right. All right, so the motor spins pretty nice. Seems really free. Right here you can tell that this is American made and serviceable, because this is a brush over here, probably another one on the other side, yes, and there's a brush right there. So you take these caps off, and the brushes are behind it. That way you can clean them, you know, replace them, you know, do that sort of stuff that you need to do. This is on a spring here because that's how it tensions the belt. I don't know much about these, but I do know that. On this end, of course, is where your wheel goes. There's one on the end here. And right here is the part that you would mount it to some sort of a tool post or your cross slide or something like that. I'm not really sure how we're going to do that yet. I'm sure we're going to have to make something. I guess that bolt right there must cinch it. What I'd really like to do is take this thing completely apart. And I want to check the bearings and the spindle here. Lubricate them. They feel pretty good though. I want to see how it's made really. Clean it up really good. Maybe paint it. I don't know. And then we'll put it back together with a new cord and then see how it works. Clearly I'm not going to power it up now. I could, but I'm not going to. Now I'm not sure what this is. It's obviously some sort of a chuck that holds a tool, like a grinding wheel. I'm not sure how that works though. But anyway, this is how this would work. Whoops, besides kicking you around. One of these belts, you see how these pulleys are crowned? This one's crowned and this one's crowned. Not much different than the old line shafts, you know, in machine shops. The crown keeps the belt straight. So essentially what you do is you would pull this forward when it's mounted on the tool post and put the belt on. You probably have to order a new belt or two. And then just let it rest back on the spring tension. And then what she does is, of course, just drive that spindle. This is the business end, of course, with the grinding wheel. You got an oil cap here. I want to see how it's made as far as how the bearings feel. lubricate everything, clean it all up. And then at that point, I think we'll figure out if we can actually put it on the tool post. Make something to probably raise it up so it's level with the center of the chuck, the spindle. And then we'll have to order some more of these grinders, grinding wheels, different ones. I got an idea what to do with this, what to use it for, which I'll go into another time. I'll show you what's in this one. It's parts of another one, an even smaller one, which is kind of cool. That's real. This would be the size that you need like for an Atlas 618. I wouldn't be out of the question of using it for something, but the only thing it comes with is a motor that's half taken apart and that little spindle deal there. So really this is just parts of one. And here's your piece for a T-slot, which is obviously homemade. It's aluminum. And so, like I said, this is just something that came extra with it, which you never know. Maybe I can figure out how to use it for something in the future. You know, it is a nice little spindle. I mean, worst case scenario is you hook this up if you need something real small. Just come up with a motor to drive it. Even this one over here, maybe fix it up and build some sort of a fixture for it so the motor stays on there and connects to it with a belt or whatever. I would imagine that there's supposed to be a bigger pulley here. So anyway, that's what was in this box. That one comes with a 3-pin plug too, which is kind of nice. But I'm not gonna, I might just steal it off that. Yeah, you know what? We'll probably just steal the plug, the whole cord rather, off of this one. I was looking inside here and blew it out with some brake clean to see if there was like a cap screw or something to take this grinding wheel off this grinding tool, and really all you gotta do is that. It's got a little nut inside of it, so the inside of this grinding material itself, I guess it would be a small grinding wheel. Inside this grinding wheel's actually got a little hex in it that holds that nut, so these must be very special for this particular unit, or this type of grinder, I should say. These are most likely spacers for different thickness ones, so I'm guessing you just put on what you need because they're both identical. Either that or, you know what, maybe one goes on one side, one goes on the other. I don't know. Now there's some marks here where somebody was holding it with something by screwing that on. I don't know why you do that because there's a nut on the other side here. This has got 2 holes right here. It looks like a pin wrench goes in there. And I'm thinking that these flatheads over here are locks for that. They'll lock those in, and then I think the ends screw off. That's what I'm guessing. Most likely I gotta take this nut off over here to get this this side off where the pulley is, and make sure I at least make a mental note what it looks like. There's a little slot in here, like there should be a dog that mates into it. I'm not sure why that's like that. Let's do that. We'll get a flathead, we'll take these screws out, get a container for this stuff, and then I'll zip this off, which is probably a 3/8, I guess. And then we'll see if we can get that spindle out. Nope, 7/16, of course. See if it just comes off. Come on, baby. All right, so these flats right there, they appear to be place where you can get a purchase point on something like this, which is just I save all these things that come with junk furniture. You know, these flat you know, pieces of like little wrenches that come with these come in, you know, come with kits, furniture kits. These come in really a large amount of handiness. And so I just put that on there, and with a 7/16, and she comes right off. You should be able to pull that right off. There we go. So there's your pulley. And again, there's no real, well, there might be a, let's take a look at this end before we go too far. Yeah. Okay, so this part right here, got a little flat on it. You can see those flats. And then these flats go into it. So it does engage that way, but the flats 90 degrees to it are what we just used to get a purchase on this thing so we can unbolt it, unnut it. So that's pretty cool. Now we should be able to take these flat guys out, these flathead screws. And I'll have to come up with some sort of a pin wrench. I don't think I have one. A pair of snap ring pliers might work though. So anyway, let's give it a shot. So I'm thinking these must thread in, and they provide the preload for these bearings if they require any. Or maybe just to take up the thrust. Maybe not preload is the word I'm looking for. To take up the thrust in the shaft so that the shaft will not thrust left and right. That's what I'm guessing, but we'll figure it out as we go along here. Well, guess what? That's an oil. That's an oiler. That's an oil hole because there's a little piece of like wicking felt in there. So I'm wrong again. I mean, I've been wrong once before, so not the first time, won't be the last. I wonder how she comes out. And wonder what this is. Oh, that's part of the cord. Never mind. Put that back in before I lose it. Well, they must just screw in then, and maybe they use shims. There could be shims in there that does this. Let me see if I can find something to grab those little holes, some sort of pin wrench or something. A couple of years ago, I picked up this little pin wrench at a yard sale. It was part of an estate. They were clearing out an estate down the road. And I never used it. I've never used it for anything because it doesn't fit anything. But I had to grind a little bit of relief in the center of it. But guess what? Once you get the schmoo out of the way, it works on that. It wasn't very tight. But I just want to see what the hell the thing looks like. Hopefully ball bearings don't go flying everywhere. I imagine it's a captured bearing of some sort, don't you think? Looks like it's greased. There's the inside of it, very, very fine threads. It's got to be the bearing. A bearing. Yeah, it's a ball bearing. Do this side and see what happens. Should I label these? I'll just keep it over this side. That one's pretty tight. I need to modify it a little bit better, but it did work. So here's the other cap. Pretty much identical, I would imagine. Smells like old grease. Oh yeah, look at that. There are shims in here. Let me show them to you. Make sure there's none inside there, stuck in there. No. This looks like almost like a spring shim. Must be calculated in there for the thrust. So now we got to figure out, I want to get this shaft out completely because it feels real gummy in there. And it really didn't spin all that great, to be honest with you. So I'm going to have to try to figure out how to get all this stuff off here. Got to be a way to do it. And then we want to get this shaft out and take a look at the bearings. I'm wondering if you have to press this out, but why would it be so much thrust movement here? All right, well, I'm going to play with this off camera and see what I can figure out. All right, I separated the motor from this, even though I didn't want to because the spring is going to... Thought the spring would jump around, but it's actually on a tube that the pin slips through, so that's not going to be that hard after all. I thought it would be harder. Put the nut on here and I started tapping this way. And this bearing is coming back, which is what I'm pretty sure is what's got to happen. And then on a press or something, you can press this one off. There's a shoulder on each side of this main spindle. I at first thought about measuring what end play it had, you know, what thrust. That's not going to matter because I think the bearings just seat up against those shoulders. But these bearings are smoked. I mean, I wouldn't be doing this to it right now. I mean, look at how loose they are. So we got to get this apart. So I'm going to go over on the press and just take a big socket like this and push straight as I can down because I think I already maybe bent the end of this where the threads are a little bit. The nut doesn't run exactly true, but it could be the nut damage too, so I'm not sure. But I'd like to get it out and put it in the lathe and see how it spins. I can straighten this out. It's just, you know, mild steel basically or something like that. I can straighten it out and make it run true, put an indicator on it, get this thing perfect, which is what I was intending on doing anyway. But the thing is, I got to get the thing off first, so I don't think it's on very tightly. Like it's perhaps a little bit more than interference fit because I just use a tiny little tack hammer to move it that far. This shouldn't bend this thing, but you never know. There we go. See, I'm not even using the arm. She's coming right through now. Perfect. This is what I should have done before. Whoops, now we're down the bottom. This little piece, this little sleeve thing that goes on the outside of the bearing, that's passed. But the bearing is not yet, and I've kind of run out of room on that socket. All right, she's out, no problem. I just actually tapped it a couple more times with that nut on there. It came right off, so that's this end, of course. So I labeled it the pulley side. Remember, this is the drive side, because it's got those little flats. You kind of get a better shot of how that works. You slide it over and it lines up with the flat on that, and that's how it drives. Pretty clever how they did it, actually. And I have this on video, so I should be able to remember how it goes back together. What I want to do now is I'm just going to put it in the lathe. I can leave this bearing on. I got plenty of spindle clearance for that. I want to run this in there and see if anything's out around as far as the tip here, because I was mashing on it earlier. Just get an idea, because I want this thing perfectly straight, you know, as much as possible. Who knows the way it was when I first started, even before I took it apart. And this side's going to be pretty much the same. Push the shaft away from the bearing and take it off. I'm not going to do that right away because there's really no need to do it. I know I can do it. I'm gonna have to do some research online to see if we can find maybe a catalog, see if we can find out what these bearings are, because I'm pretty sure they're pretty crapped. I mean, they don't feel all that well either. They're pretty kind of rough. So I'd really like to replace those. This one's a lot better, it's feel-wise, but you know, it's definitely got some play. And like I said, definitely some radial play too. So we can't have that. We're gonna have to figure out what bearings these are and put them in. See, one side of the bearing is flush up against the edge. So the center is flush up against the edge. The other side is recessed. There's a little step on the center part of these bearings. Yeah, a little step right there, like a little shoulder. This one has that same exact shoulder. It's just harder to see because it's up against the shaft. So this shoulder goes in. So it is the same bearing. I thought for a moment it wasn't, but if you lay it this way and look down that way, you can see that that shoulder lines up with the outer edge of this bearing, therefore the center does as well because it's butted up against that shoulder. Problem solved as far as that goes. Sometimes I'm completely moronic. Get you in a little closer. Let's see what we got. All right, I'm on 1,000 RPM now. I don't want to go that fast. Let's do 600. Oh, that's pretty good. I may have mucked up the threads a little bit, but I ran a die over them once. I may have to do it again. It'll still bolt up the pulley. I mean, it doesn't really have to be that tight anyway. It's got these little dogs here to grab it. So, you know, if we don't have tightened it that much, we just won't. But that runs nice. That runs nice and true. Let's see what the indicator says for the hell of it. Let's see. Well, you got about 3 thousandths, 3.5 thou. At least right there. Okay, that is moving 3/4 thou or so. Not terrible. We may be able to do better. All right, so let's see. This is pretty good. Like I said, I gotta take a look at these threads. I may have just kind of bugged them up. I think I mushroomed the end out a little bit is what it was. I ran a die over it once. I'll fix it. It's not gonna be a big deal. I'll fix it up. It'll definitely hold the pulley on there. I'm not too worried about it. May just put a new nut on it too. The nut may have gotten a little bit screwed up internally as far as the threads go. Usually it doesn't though. It's usually the male side that gets screwed up when you wrap on it. And like I said, I used a little tack hammer, so it really wasn't a whole lot of force. So the next step here is I'm gonna try to find some bearings for this. If I can, I'm not sure what I'm gonna do besides put it back together with these. In the meantime, once I do that, we'll take the motor apart and get that all cleaned out on the inside. I'm sure it's okay, but these are so simple. There's really nothing to them, especially when you have the externally accessible brushes. They're the bitch to get back in when you have to spread them apart and put like a little piece of wire through, and it's a pain in the ass. But when you can get these out from the sides, it's absolutely easy to do. So we're gonna take the motor apart a little later when we come back to this, and we'll clean it all out, make sure it's good, lube any bushings or bearings in that. And like I said, in the meantime, we'll see what we can figure out to get this thing, you know, bearing to back up. So we'll see you then. All right, so a few days gone by. We're gonna get back on the motor side, but I wanna talk about the bearings on this tool post grinder because I got new bearings. I'll explain how I figured that out here in a sec. This is the bearing on the wheel side. You can see it's real sloppy. And the other one is yaw, which goes on the pulley side. It's not quite as bad. That's the one you saw me drive off before. I should say half-ass drive off because I didn't know what I was doing. But this one is still on, and you can see again, it's real wobbly. So anyway, I took the one and I drove off. There is a 38 K as in kilo, T as in tango, 38 KT on this bearing. Both bearings, same bearing. I ordered two 38 KT bearings from a place called Find Bearings. Let's see now. Locate Ball Bearings Direct, California, on eBay. These came off eBay. So here's one of them. You can see that you do have that little step there. And on this side, you have a seal. The way this was set up in here, this little step here went in toward the center of the spindle. So it went like this, which is perfect. Because what I'm going to do is I'm going to leave these seals on the outsides here. And I'm pretty sure you're supposed to have them there anyway to keep the oil in, because this is not a grease bearing. It takes some sort of a light oil. And inside the housing here, which I still got to try to get this crap out of here, you can see there's a felt wick down inside there. I think I pulled one out and showed you earlier. But there's two of them that go vertically and one big one that goes horizontally across the center of this thing. According to the parts breakout, they are removable. And you can see they're pretty wet with oil, but I kind of like to maybe clean them out or something, if that's even possible. So the oil from this little oil cap right there goes into the felt wick, spreads out, and then goes to the bearings. And I think if we leave the seals on the outside, it'll contain it rather, so it doesn't want to come out the ends. That's the plan at least. For now, what I want to do is I want to set these aside. Well, I'm going to do this off camera. I'll get this all cleaned out. Best I can at least. I don't know exactly if I'm going to be able to or not, but it's definitely got oil in it, but I don't know how old it is. But I think we're going to concentrate on the motor now. I love these little flathead screws. Get this cover off. Okay, so this is pretty simple. We've got the hot going into the switch, coming back out the switch, going into the motor, the neutral going down. I'm assuming that's a neutral. Yeah, because there is a ground on this. I said before no ground, but this is what it was. Apparently a bullet connector. It's weird. Ground goes right here. We'll take that off right now. So the main thing we got to watch out for here is length of wires. It's really short inside there, one side of the wires. We may have to reuse this part of the wire up here. Well, I don't want to lose the switch either though. You know what? I don't want to cut that off because the switch is probably just fine. All right, I'm just going to cut the plug off over here, the wires off the plug, and then we can pull it through, at least take it apart. Ah, there we go, that's one. Little cap. Oh, there it goes. I was worried that one wasn't gonna go. This is the brush. I don't know how long they're supposed to be, but they look pretty short. I don't know if I can get new brushes for it, but I might check. So, this is a Series 11. I should probably mention that now. With that in mind, if you go on Dumore's website and look for Series 11, you don't find it. I found the information on the vintagemachinery.org. Yeah, well, we're going to need brushes for sure. Yeah, look at that. This one's broken. Ah, fart knocker. Well, it's a good thing we checked. Anyway, vintagemachinery.org has the drawings and stuff for it from an original Dumore catalog or parts list, which is pretty handy. Some user put it up there, which is really nice. Meanwhile, we can just take the rest of the motor apart and take a look at it and see the carnage or lack thereof or whatever. We got to get in here and clean it all out and lubricate the bearings, check the bearings. There's a long one, said the wife. Yeah, she's pretty grody in here. Oh, you know what? I know what it is. We got to take this off and the whole thing pulls through. That was pretty stupid. Let me go do that. Okay, here's these two springs. That's what was pushing out at us. Wow, what a mess. I'm thinking the springs just go on the... Yeah, you know what? See how these are set way back inside there? Those holes? These springs just go on the big long screws like this, and apparently provide that thrust to keep this plate back in there and also pull the thing together. So I'm pretty sure it just does that. This motor has seen some use. Okay, so that's what the innards look like of the stator, if you will. This would be the rotor. We just looked at with the commutator on there. It's just dirty. I'm gonna clean this out, you know, just typically using like simple green, just blow it out with water. It's not gonna hurt nothing. Or just blow it out with air and some brake cleaner or something. I don't know, I'll figure something out for it, but it's gotta get cleaned out. There's no question about it. It is a mess in there. This is the front bearing, and it's in nice shape, but you can feel well, you can't feel it, but you can feel when you start to turn it, it goes easy and then tightens up, and that's because of that gooey grease in there. So it is a sealed bearing. We need to press that off and then just pop one of the covers off. There may not be one on the inside, I don't know. And then we'll clean the bearing out and re-grease it, so that'll be fine. As far as the rear bearing goes, I'm gonna figure out how to get that one out of this cover. There's a fan back inside here, which is the cooling part of it. And I think those springs just hold this plate in here, which is kind of like a fan shroud, it looks like. Now, as far as the commutator goes, we'll just put this in the lathe and we will cut this commutator back, but not all the way, about up to here, because that's where the wires are made into it. So you can see the line that the brushes make. We'll just go back almost to the edge here. We'll clean that commutator up and then clean out each one of the spots in between with a little razor knife to separate them again. This will be fine. That's what, you know, the old Atlas 618 is kind of like an old armature lathe. That's really perfect for it. That's really what they were used for, primarily. The back bearing feels good. Oh, it just comes right out. Well, there you go. And then there's a spring dealio for thrust on the back side of here, too. Oh, yeah, look at that. That's a pop-out cap on the back for, I don't know why you have it, because there's no way to lube this. So there's that. We can take this off now. And there's a fan. And again, the back bearing. So doesn't feel bad. They just need to be cleaned and re-greased. And once we pop the bearings off, I can put it in the lathe and take care of this. I'll show that. We're going to skim that. Maybe we'll fire up some old high-speed steel and do it old school and just cut this back and then clean it up. But I need to go in now and try to find some brushes for this thing. Go ahead and turn our attention on this armature. We need to get these bearings off. So I got a bearing splitter kit from Harbor Freight, because I don't have any bearing splitters, but I do now, which is nice because they come in handy. I'm hoping that this is not more than an interference fit like it was on the actual spindle there. For now, I'm going to try to push this armature out without blowing this thing apart, because this is an awfully tiny shaft, said the wife. I screwed a nut on this. This was dumb trying to push that without anything across to take some of that load. Luckily, I didn't push it very hard. The nut went right on. So I'm going to heat this a little bit, because this is a collar up in here that presses down, just like on the spindle. This collar that comes off with the bearings. I'm just going to hit it with a little bit of heat. Yeah, that's about all the heat I want to put on that. Wish I had an arbor press that would seat on this a hell of a lot more square, because that little shaft is not going to take a whole lot. There it goes. Finally, yeah. Just had to break it loose. All right. I don't know what happened to the audio, but somehow I lost it. Right now I'm just pointing to the witness marks of the old brushes, because we're going to go ahead and turn this commutator down. So essentially we can't go back too far because the wire is attached to the copper right there. So I'm kind of pointing to about the maximum amount we're going to be able to go in. I've got a piece of high-speed steel in, which ultimately doesn't work too well, which you'll see here in a moment. This clip, I'm just showing you the overlay of the new brush, the replacement brushes, which I'm going to cover here in a minute. A little bit further on and cover how I made these brushes work, because they don't exactly fit out of the box into the spaces in the cover where these penetrate through to the commutator. So it fits nicely as far as alignment, so we know they're going to work fine. And then we'll just cut back again far enough to make sure that we clear enough area so there's not any remaining bad parts where these brushes are going to sit. So we're running 1,000 RPM, about 8 thou per revolution, high-speed steel, interrupted cut. And it doesn't go too well here. As you can see, the surface finish is pretty terrible. It essentially just rolled everything over and turned it into it looks like an abrasive. So I'm going to switch over to carbide. We'll clean that up. That's an aluminum insert, 800 RPM, same feed rate. The reason why it's high-speed steel failed, because a very sharp tip interrupted cut and the RPM too fast. It just burned the tip right up, even though that is copper. So that's cutting real nice, and you'll see the finished product here in just a second. Initially didn't cut it deep enough. I was scared of getting into the wires where they attach the copper, but I eventually brought that in deep enough where it very well clears where the brush is going to sit. So I'm kind of demonstrating that here right now. So I was thinking that these lines right here were the wires. That's why I was stopping up here. But the wires are here. not there. This is the separation between the segments. It extends all the way back here. So that's a wire, that's separation. So I cut this back a little further, make sure I'd have the width for the brushes, and I definitely do. And then we clean this thing all up. It would have been a lot easier to clean between the segments if some dummy hadn't put a high-speed steel bit at too high of an RPM on an interrupted cut and rolled the damn thing over. I wonder who that was. But I got it cleaned out real well, and to prove it out, I'm going to test a couple segments with the digital multimeter. I don't know what it's supposed to be, but if we go between two segments here and there, and then all of a sudden the resistance is like doubled, that's 0.6 ohms. That's about right, I would say. 0.6, 0.5. I mean, I can go through each one of these, and maybe I will off camera. 0.6, 0.6, 0.6. You see what I mean? 0.6, yeah. So I would say this rotor is definitely good, as long as we don't have sharp edges here that are going to destroy the brushes after 3 RPMs, which of course originally when I cut it with that high speed, that's when it wouldn't have even worked, but it would essentially been a grinder, a carbon grinder. So I'll polish this up one more time off camera. Otherwise this one's pretty much done. And as far as the bearings go, I did get caps off one side of it, this side, and I'm in the process of cleaning these out. They feel fine. They're just full of, you know, ancient grease. I don't know what year this thing was made, but they are just full of ancient grease. And it's not even coming out with gas. It's so petrified. So I'm going to heat the ultrasonic up. I got a bunch of small parts I want to do from this thing. I'll put it all in at one time and see if we can have the ultrasonic blow this crap out of here. And then we'll repack them. And I'll go ahead and put these covers back on. These covers have little felt in them. And this is kind of like a felt seal, fiber seal on this side. And of course that's the side that goes in, this is the side that goes out. All right, so I went ahead and put the bearings back on the armature. Ended up damaging the threads, but fixing them, it's a long story. But they work fine. The nut goes on fine. Front bearing, rear bearing, a little washer, little slinger, whatever that is. They feel real well. Let's set that aside. We're going to work on the brushes now. As I mentioned earlier, the brushes are not available for this. I can't find them anywhere. This is a generic brush from McMaster Car, which appears to be about the right size. The spring length is about right, I think. This little end that's got the little tabs on it that goes inside this part right there, that appears to be right. But the trouble is this will not fit. As you can see here, and it is a little difficult to show you, there are some slots kind of probably broached in there, flats I should say. And that keeps the brush oriented. You can see that there's a radius cut to that brush. That radius matches up with the horizontal part of the commutator which comes through. So that's what keeps that in that orientation. But as you can see here, it doesn't fit. I got a little better light for you there. See if you can see that fact that it will not go into this hole because it's too big. Essentially it's too fat this way and it's too tall that way. Unfortunately, there's not a whole lot of room you can take off because the spring comes really close to the edges. But we got a solution for that. So here's a brush that I modified, and I'll show you how I did this. And it slips right in, no problem, fits perfectly, goes in and out. That's strangely satisfying, and it'll work just fine. So I'll show you how I did this on the mill. Now Ichabod's playing with his toy over there. Sorry about that. I'm not going to interrupt him doing that. He deserves to play with his toy. All right, so the first dimension we're going to accommodate for on these brushes, this one right here. This is the width of this thing right here. And we need to make this so this brush fits, which it does not right now. You see that this part is just too wide. Now the width of this, again, that goes from flat to flat, is about 325 thou. The width of the brush is 373 thou. I'm assuming it's for a 3/8 brush holder, therefore it has a little clearance. So we'll say 373. So we're going to take off 50 thou. We're going to bring it to about 320 something. 25 on the side. Now, there is enough clearance on the edge there between where the spring seats over that little cylindrical spot and that flat edge to make that clearance. I know that to be the case because I did it on this one. So you can see this is what it's going to look like. Those relief cuts to make those little corners we'll make after this. But right now we had to bring the width down. A little bit of a finicky setup, but I'll show you how I do it. All right, we got a parallel in, and this is where you need narrow parallels. And I almost ordered a set recently, and I didn't, and I should have. because these parallels are a 1/4 inch thick, and so is this. So we can't clamp down on the work because it hits the parallel first. Actually, we'll do it this way to start with. And so what I end up having to do is I end up having to shim just the work itself. The very top here, like I said, it's very fiddly to do. And we're just going to hang it off the edge here so we don't, scrunch the spring. Is scrunch a word? Generally how I did the other one is I come across from the other side, put it in here. And it's just a matter of kind of getting a little fiddly. Just having the shim between the work, which is the carbon shim, with the carbon shim, yeah, the carbon brush, and the vise, which is not the easiest thing to do in this situation. And at this point, the parallel should be loose. So we'll take our Mortske repair screwdriver and we'll make sure that that is the case. And it's it's pretty loose, so we're good. All we want it to do is be setting the height, in other words, so it's flat or parallel. And as far as how much to crank on this vise, well, I put a lot of force on me. I cranked the shit out of it. Just kidding. I'm just going to put a little bit of force on it. That's a little bit, just to cinch it in. So now we're ready to cut this. So all we do is bring the cutter down with just a 1/2 inch 2 fluted end mill. And like I said, we're cutting the whole top, so we're just going to go straight across on it. Set the ZDRO. All right, I'm going to cut off 15 thou. Now we're going to go to the full depth of 25. All right, that's one side. All right, now we're going to go ahead and set up to cut the width here, the width of that slot. You can kind of see it running down lengthwise. So we're going to measure it like this. I'm going to measure that width of that slot and then be able to translate that into edge cuts. We can't cut the whole thing. Let me show you the other one, be a better example. So you can see on that side of it, if we cut it flat down, see the narrow section? That would definitely hit the spring. But on the corners we have some room, and we only need it to have a little relief to fit in. So I went in, I don't know how much that is. I can't remember when I did this one, but I kind of eyed it in. Whatever I went in on, that's what I'll duplicate on this other one, and whatever that depth needs to be. So really we're only going to cut the sides on this little corner to the depth for that little step right there. So that's pretty easy to calculate out or just measure out, same way with the ZDRO, just by measuring this width here, which is 220 thou, and it's 250 thou for the original one, or the unmolested one, I should say. So it's going to be pretty easy to do that. We're going to have to take 30 thou off total. So about 15, maybe 18 on a side. I want it to be a fairly snug fit, but I don't want it to bind. The other one's pretty much perfect. Let's see what the other one is measured up to give us an idea what we need to do. It's, I went down to, looks like 208 or so. Yeah, we'll say 208, it's a good number. So we're starting off at 250. So we took off about 42 or 44 thou total, not on the side. But this fixturing this thing's a real pain in the ass, so that's the reason why I thought this was interesting to show. I'm going to use a different parallel, a little higher one. Actually, we don't need to do the same thing as with the shimming because this is 3/8 of an inch wide and the parallels are 1/4 inch. So all we do is just use a taller parallel because we are up higher on a narrower surface. We're going to go ahead and get this cut. So I just need to touch off on the side because I've already set the depth of 21 thou. And then we're just going to move it in by eye. See, I've dropped the spring down out of the way here so it doesn't get caught on the cutter. Just kind of lower it down. It stays there pretty good. And we'll do the same thing on the other side. But for now, we just got to touch off and then move in and make the cut. And then we'll do the other side and then flip it over. Now I know we're climb milling here, but it don't matter on this material. All right, we're gonna take it out and see how we did. It should fit based on the numbers, but how often are my numbers screwed up? Quite often. Say it out loud. Quite often.
Quite often.
Now it's a little bit more drag than I like, so I think I'm going to, yeah, we need to bring the thickness down a little bit. What I mean by that is this thickness is just a little bit too high. So let me go do that, and then we'll come back and double check it. I got a little chip on the end of this one, unfortunately. I think I bumped it with the cutter when I was setting 0. Yeah, I mean, it's not terrible. It's plenty of material there, but I still don't like it. You know, I'm kind of anal and OCD if you haven't already figured that out. But that's nice now. We have a nice, smooth fit. That was just a little too thick. So again, my math was off a little bit, but I'm gonna go out to my truck and get my surprise look. Spring fits down inside of it, no problem. So these are gonna work just fine, but I wanted to show you how I did this. Pretty soon we're gonna be going into full reassembly, but we need to, at least on the motor. We'll do the motor first and then we'll deal with the spindle separately. Let's go ahead and put the motor back together. Off camera, what I did was I extended these wires out and soldered and heat shrunk them. That way they can come out the top here and we can just cut them to length. I also tested this stator. I'm not sure if it's good or not because I don't know what the normal readings are, but it comes up, you know, between the two spots here, this one and that one, and then this one and that one at about 1.5, 1.6 ohms, which sounds about right for a stator on an electric motor. And they're both the same. One thing I didn't test was, you know what, I should probably do that real quick. I did not test wire leads to ground. Now this is giving me a reading. 14, almost 15 mega ohms. This one does not. We may actually have a bad stator here. I wish I had tested that yesterday. Yeah, it may not work because of that. One of these windings in here apparently is going to ground. It may just be a reference amount. I know it's not supposed to have any, but it may work nonetheless. I didn't realize that. I should have checked it yesterday when I was playing with this thing. I actually cleaned it, and I hope that didn't cause the problem. You know, because I basically used soap and water. I figured this is all varnished. I seriously doubt that that is a connection from any type of, you know, wetness or moisture. This has been sitting all night. Well, we're going to try it anyway. It's such a high reading. It may only affect the magnetism of this particular coil a little bit. It may still work just fine. But it is what it is, you know? Okay. So like I said, I'm going to get this back together. We'll do it in a time warp. It's a little tricky here. Down inside there you can see you get those two bosses and these wires clip on there. So I'm going to have to work those in. And I got the shields behind them. They didn't come out too hard, so I'll just pop them back in. Oh yeah, and there you go. I almost forgot this plate. That actually goes in first. It's like a fan shroud inside here. Then the springs go between there and there. You know, I'm doing this majorly dumb. Assemble the rear section and shove it in the front. Gee whiz. That's pretty stupid. Yeah, so I got that spring washer, which provides a thrust on this. This goes in here like that. Okay, so we just leave that there. Perfect, now we're seated. Sometimes I wonder why anybody watches these videos ever. Now, because it seats up against the shoulder inside the body. Then you put these guys in like this. Now, why couldn't we just turn around and just shove the whole damn thing in? All right, that seems okay. Yeah, show you. I mean, the bearings aren't perfect, so it's going to be what it is. Now, there's supposed to be this little... I hope I can get this in from the top. I'm not 100% sure I can. I'm pretty sure I can pop this in from the top, which is just a shield over top of the commutator where the brushes are. But I want to put the brushes in first so I can see the contact. So let's slide the brushes in so we can see the contact on the side of the commutator. Here's where we find out whether or not we screwed up or not. They fit in nice. I bent the little tabs out a little bit because they have to go around this part. You can see it kind of has to go over like that. Slides over it, or lays over it. and the cap goes on top. Hopefully the cap will fit too. Let's put a cap on, that way we can keep it in place. Geez, I hope it works. I would think it would, just as long as it stays centered. Whoops, I guess not. I think we can work around that. Gotta do some modification to the little wings. They're sticking way out the side and not allowing the cap to come around it. That's the problem. So, all right, so if I hold some pressure onto that brush, you can see where it contacts a commutator there. I can get a wire out of the way. That's about right. I just gotta work out the details on the cap part. These are gonna work just fine. All right, easy solution, see? An unmolested one, you cut those tangs off the side altogether. Get them out of the way. And then this fits inside the cap. Then you just put that in and it presses up against that part of this body, which of course is connected to a little, you know, clip shaped. And then this just bottoms out on top of there anyway. So it pinches it right in and that little cap keeps it centered. And where did I put my regular screwdriver? Yay, problem solved. Let me do the other one. You know what, we could test it at that point. We can just put power to these two wires, just kind of work up some sort of a plug to 120 volts and see how she turns. These are the only butt connectors I had for this, so it looks kind of gaudy, but I do have a ground hooked up. I'm not gonna chance getting shocked. I do remember this left one, this left one here was connected to the switch, so that's hot, so I got it on the black. I'm gonna plug it into a surge protected strip here and see what happens. Contact. Neater than a Skeeter's Peter. Got a little arcing on one of those, that might settle down once it wears in. Yeah, that's better. See? I don't know if you can see that on that left one. That'll get better when it wears in. You know, this bearing on the back side is getting hot though. I don't know, let me try it again. See what it blows out any warm air. Yeah, a little bit. These bearings are getting warm. 93, 91 degrees, 90, 75. Doesn't work well on shiny shit anyway. You know what, it might be the way it is, I don't know. Well, we're gonna run with it. And I got the shield in, I was talking about before, that popped right in. So we just gotta wire it up to the switch, have the wires coming out. Well, actually, we can just do the whole plug. We can get this whole thing wired up because this is the only thing it goes to. So I'll do all that off camera. We'll get the motor to the point where it's done. Alrighty, all back together, all connected. Works good, pulley's on. This thing definitely blows some air. Now that this cover's on, sucking it through the front holes the way it's supposed to. I mean, you can see it. She's got some airflow, so imagine it'll run a little cooler now. Like I said, I don't know if you just heard me. It'd probably run a lot cooler now that that's pulling air directly through the thing, but the back bearing definitely gets warm. I may order some, I did find some aftermarket bearings for it. I may order those, just have them on hand off eBay. They're not the brand bearing that's inside here, which I forgot the name of it, but I did look it up, and it's one of those bearing companies you got to order a zillion of bearings from to get, you know, probably industrial supply bearings. How I made the internal connections inside here was with these guys, which are called solder sticks. They look like crimp connectors, but they're soldering connectors, which are essentially a crimp connector with a solder instead of just a crimp part. So this little silver part melts when you hit it with the heat gun, and then the whole thing crimps to, or I should say shrinks together and creates a nice seal. These are probably better designed for like trailers and things like that, but it worked really well in here. And don't let the length fool you, said the wife. Once you heat these things up, it gets really soft. I know all about nowadays at my age. What happens is you can actually bend and flex these things around, no problem. The only inflexible part will be the center part where the solder is. So these things are stiff now, but not necessarily after they get hot. It worked really well in this application. I really liked it. I wanted to put my amp clamp on here and see if it was pulling a 2.7 amps, and I did try that, but the amp clamp's not reading anything. It must be broken or something. So I can't really tell you that. It does say 40 degrees centigrade continuous rise. I guess I don't know if that means that it raises temp over a certain time by that amount, which would explain why the damn thing gets so hot, but I'm not going to be running it for an extended period of time anyway. So I think it'll be good. Yeah, it's a good example of just good practice repair operations, and then just searching around and see what we can use aftermarket parts-wise or generic parts-wise, in particular these brushes. And then we just repurpose the cord off that other one that I got. So anyway, that's it on this one. We move forward now, and the next set of clips will be on the spindle. Then we'll put it together and we'll set it up on the lathe and give it a try. Gotta work on the 3-jaw on the lathe here. It's kind of gunked up on the scroll, so gotta take that apart, and I think there's a burr in there. But anyway, that's why that's here. That's not what we're here for. What we're here is to test this thing. As you can see from a little B-roll clips I'm gonna put in here, I was able to press the bearings in. I did one side. This is the side I did first because that was the one that came out last. Then I did this one, pressed the sleeves back in, and then screwed these guys back in. I lubed it up with the same lube, I think it's ISO 32 or 68, one of the two that I use on the lathe for the lathe bearings and stuff. That's pretty good oil. I've got the, I did take that center, that big section of wicking felt, took it out, you know, wiped it off best I could, put it back in, and I lubed these guys up, and I lubed all this up with this ISO oil, and these two guys, the wicking felts in there. There's plenty of oil, and since we've got seal bearing on the ends, which the other ones didn't have, we could probably oil this up pretty good, and we're not going to have any really squirting out at us. So anyway, I got it all back together. It was really easy to put that pin back through. And then, so let's give it a test right here in the bench and see how it spins. Obviously, I don't have any wheel installed, but we'll show you that here in a bit. Contact. This is the original belt that came with it. I did get a belt from McMaster Carr, but I don't know if it's going to work right. Let's try that out and I'll show it to you real quick. It's a 15-inch long, half-inch wide, or 15 and a half, whatever that was. But it's made out of like plastic. I don't know if it's going to grip the pulleys well enough. I'm going to try it out real quick here and see what happens. You never know, it might. I don't know. It's just... we're not going to really know for sure until you get a load put on the thing, but let's see what happens. That works pretty good, actually. Well, that's not bad. It's actually gripping pretty well. I didn't think it would. Let's go ahead and leave that on for now. What we have to do now is we have to come up with a way to adapt it to our compound rest and my compound rest, and I'll show you how we did that here in a sec. All right, at this stage of the game, we finished up the motor and the spindle side, except for this part. We need to be able to attach this to my compound rest via a T-bolt and a nut that slides through this guy, which is that part on the spindle side assembly that this thing slides up and down on, and you can adjust that height, you know, to center it up to whatever chuck that you have in the center line of your lathe. This particular piece, I do not want to modify and open it up to, like, for example, this size here, which is the quick change tool post, the wedge style that I put on, and I have a video on doing this one pretty far back after I got this lathe. So what I did was I took the piston style tool post out, the quick change tool holder. This is the tool post bolt. This is really a T-nut, although it does look like a T. It's kind of half rounded here. That's why I have the 4-jaw out. We're going to machine this down to accommodate this, which would be the original tool post T-nut for this thing. I kind of goofed up. I thought this was only to secure it inside that box. It's a dual purpose. does that and also attaches it to whatever lathe, which goes to show you this is a pretty small unit for my particular size lathe. It would definitely be more suitable for back like the old 618 Atlas or maybe one slightly bigger, but it'll work. But the thing is, I don't want to bore this out and weaken it. So what I'm going to do is I'm going to take and cannibalize the T-nut, the T-bolt rather, from that piston style tool holder because I can still use the piston style tool holder over here if I needed to, because this bolt here is the same size. I tested that, it's no big deal, no problem. So we can lose this. We'll turn it down to which 3/8 of an inch. This is a big amount of material to take off. That's 3/8 diameter. We'll turn it all the way down to this step right here. And then we'll rethread it for, I don't know, whatever we choose to use. I don't know if I'll use the original nut off this. This is a fine thread, probably 3/8 24, I'm guessing, for the thread. I can do that because the machine's set up for imperial threading right now anyway. So it'd be a lot easier to do it this way than reset it up for a metric thread. First thing we got to do is get it indicated in on the four jaw here, and then we can commence to turning it down. We'll just turn the whole thing right down to 3/8 of an inch, and again we'll thread this end. See how close we got just by eye? 55 thou, pretty far off. To the right of the indicator is plus, to the left of the indicator is minus. So if this is the high spot right there, and that's the low spot right there. So we're about 54, 55 thousandths low. Got a little problem here because of this half circle that's machined into the bottom of this thing for whatever reason. The jaw fits into it too well, and you can't bump it around. So what I'll just do is I'll just put a piece of steel across here to bridge that gap. That way it will be easier to do if I can keep it in place. You see my point here is this has got to be able to kind of slide around. That's close enough. Within a thou or so, that's fine. I've got them all tight, and over here we have a center, the live center. So I'm not going to worry about indicating over here because the live center is taking care of this center. All I needed to do was bring the workpiece in with the chuck. Touched off. This is 625 or 5/8, 0.625 imperial. We need to go to 0.375, which is 0.250 or a 1/4 inch, or in this case 125 on a side, 1/8 on the side to bring us down to that. I'm going to take this high spot down to this level here to 625. So we're going to run only 800 RPM, and I think it's 8 thou per revolution to start off with. Final cut, slow the feed down. I wanted to go about 2 thou heavy because it's hotter than a $2 pistol, but we're right at size. It's all right, it's not going to the moon. Not gonna worry about it. That'll work. But yeah, that's definitely 3/8 24. I'm just gonna duplicate that. The nut isn't in the best shape, but I can always get another nut. I think I'd like to get a 3/8 24 flange nut for it. That would be a little nicer, I think, for it. So let's see. We're gonna need to set up for threading for 3/8 24. So let's go over to changing the from the feed screw to the lead screw, and then, well, actually it's the feed shaft. That way we can do threading. So for 28 threads per inch, I need to set to C8. I'm already on C and 8. So I want to go 28 threads per inch. Yep, C8. We'll run at 220 RPM, which is 3B. All right. There you go. Minor diameter for 3/8 28 is 0.332 imperial. We got to take off about 21 on the side. I'm debating whether to advance with the compound like you're supposed to at 29.5 degrees, which is set out right now, or as close to it as I can get, or just go straight in with the cross slide, because for a thread like this, it probably really doesn't matter. You can get a much more accurate depth as far as your thread pitch, or I should say minor diameter goes, but maybe we'll just do the compound, and when we, I'll monitor it up here, and then we'll figure out where we're at as we go along. Okay, cutting oil, where are you? We'll use some anchor lube. Josh Topper from Topper Machine up there in Wisconsin, he digs anchor lube like hugely, so.
All using the anchor lube. Anchor lube here. I should really try the anchor lube. The anchor lube.
All right, keep calm. It's just a joke. Just having a little fun at Josh's expense. He's a really great manual machinist, and I highly recommend his channel.
In the interest of time, I'm just gonna buzz through this. Not so good. Huh. Well, you know what? I'm gonna use cutting oil. I'm gonna try that. We'll just chase it. We'll leave it at the current setting. Because that does not look good as far as the threads go. I'm not really sure why it's doing that. I'm gonna bring up the speed too. Oh yeah, that's a lot better. You know, I'm not really terribly impressed with that anchor lube, to be honest with you. Anyway, I'm gonna bring it back when we're pretty much finished. We are almost there. So, a little bit more. All right, folks, we finally got ourselves a touchdown, and it's not without some drama. I originally cut these threads and kept trying this nut, and it wouldn't fit. It would just start to fit, and I cut a little bit more, cut a little bit more. Then all of a sudden, the nut just went like this, and I went, what the hell? I was cutting a 28 thread pitch. Did I say 28 before or 24? It's supposed to be 3/8 24. I set it to 28. Then I re-welded this up and just turned it and started cutting it again. And I started cutting 28 threads per inch again. Then I caught it in time and brought it down to 24. Now she's just fine. She'll be just good. Just a little bit of play in there. It's a really nice thread. So, all right, we're gonna hook it up. Just put it on. We're not gonna grind anything, but I wanna assemble it and show you how that works. And then we'll see if we can adjust the center height. This is 9/16. So let's tighten it up. Oh yeah, we got a good tight on that. And I'm just kind of, you know, screwing around with it here as far as that goes. Oh yeah, that's right. You know what? We got to spin it around because I want to see if we can center this spindle pretty easily. We'll just go ahead and put that live center back in. This is just for a quick reference. But I can see right now we're going to have no problem doing this. So let's snug it down. That pulley gets warm where that belt is. I guess it would normally though. This is not a continuous duty tool, you know, said the wife. But in this case, what we do is we loosen this lock bolt over here. There's a lock bolt on the side of it that has a thing inside there that pinches down on this mount, the stand for it, which is really the tool post for it. And you can move it up and down. So let's go ahead and do that. And we can move this around. And you know, this again, this is just kind of, I'm eyeing it in right now, but I just want to make sure it would actually line up. But you know, with this kind of adjustability, it's really not going to be a problem. You know, while it's set up this way, what I'm going to do is I'm going to put a wheel on it. This is an actual Dumore wheel that I ordered, 1.25" diameter. I think it's 86 grit or something like that. Rated for 18,500 RPM, which I seriously doubt this thing's going to generate right now, with the proper 1/4" hole in it. And remember when we took this apart originally, these two guys were on the inside of the shaft right here because they had that other wheel on there. Well, these are the cups for that, for any wheel that you put on, like you do on a bench grinder. There's one there, and I was looking for this third nut because you got one here and you got one here that I took off to do this work. And I'm like, where's my third nut? It was inside that wheel that had that hex made into it, which obviously is not a Dumore wheel. So we're going to go ahead and tighten this up. So anyway, I took this flat tool I was talking about before, the one that goes in here, that little flat. I ground it open so it actually does that. Anyway, that goes on nicely. Oh, and we can tighten it up really well. So now we've got ourselves a wheel on here that we would have to dress, of course. I do have a wheel dressed diamond if I need to use this. but now you get an example of what you'd use for this as far as a wheel goes. Let's go ahead and plug it in and turn it on to spin it right now in this position. All right, we're clear of everything? Yes, here we go. It's probably not the best belt for it. Let's put the other one back on. As far as that material goes, but this one's in pretty good shape, so we'll run with it. Yeah, see, that's a little cooler, so the other one must be slipping. You know, there's a certain amount of energy this takes to overcome friction naturally, even though it's pretty, pretty smooth as far as it's running, as opposed to the way it was before. Everything requires energy to overcome friction, so, that's why they make Astroglide. Never mind. So anyway, there you go. So last but not least, I'm not going to run it anymore. We'll just unplug it for now. How we would operate this is pretty simple. We would simply place it in the angle of the dangle that we want. In this case, we're just going to spin it around like this. So you can see we're addressing the chuck now as far as coming up and if we were going to grind something. And if we can also do it at an angle if we were doing some other type of grinding. Pull this back. We can pull the compound back all the way if we have some issues with distance. Because let's say I wanted to use this to grind the face of a valve. That's what I would use this for. I address whatever, like this wheel to, or a similar wheel. I have another one too that's a little 1/8 inch because there's a little adapter that I have for this. And you can put the 1/8 inch type, 1/8 shank. And so you just put it at the appropriate angle you're going to put it at. And then you can run the compound in, for example, at 45 degrees. If this was at 45, right now it's at 29.5, but you get my picture here. So you can run it in and out and put it in line with whatever degree you're at, and then you can grind it at an angle or what have you. That's essentially what my idea was for this, is because I like, when I've done valves in my old Atlas 618 with a Dremel and a special mount that I made, and it worked great. This thing I think will work even better because, you got the proper wheel, I think, and you certainly got a nice tight tolerance, and it's perfect for something small like that. This is definitely a smaller unit for this size lathe with this kind of swing. It'll work for what I want to use it for. That's just one example of what I want to use it for. Another example might be to true up the jaws in my 3-jaw. When I was running this spindle in and out on an indicator, you may notice there was a couple of thou run out. Well, I put a precision pin in, which is an old wrist pin, into the 3-jaw, indicated that. I had the same run out. So the run out's coming from the chuck. I don't know if it's coming from the chuck where it mounts on the backing plate, on the quick release, those pins, or if it's coming from the actual chuck itself. And we can fix that. I don't exactly know how right now because there's a special way you have to lock the jaws. You can see that these on the 4-jaw move. We could actually correct that. We'll stamp that, that chuck so it only goes in one way. In other words, you always line up the little dots that you stamp. And then if you grind the jaws in, then it'll always run true. That's another thing you can use a tool post grinder like this for. Yeah, I'm really liking this thing. It was a fun project to do. So that's it. As I said before, it was a fun project to do, and I really enjoyed showing it to you. This is really a passion of mine to revive old tools. This was more of a refurbishment than a revival, but I guess a combination of the two. And I think I'll get some good use out of it. I paid $350 for this, cash. The guy wanted $500, which is way too much. He said it was working. Well, he didn't say it was working. He said it spins, and that was true. So that was what the marketplace ad said. So that was not a lie. But it obviously wouldn't work with the brushes that were in it, as you saw from this video. But again, it was fun coming up with solutions to things like that and milling them in the milling machine. I never milled carbon brushes before. Yeah, who knew, right? And then getting it to the point where we could actually use it. So I'm going to put it all away now and get all cleaned up, done for the day. And then we'll get this video up for this Friday, hopefully for you to enjoy. And if you did enjoy this, you know what you need to do. Subscribe, ring the bell, share, like, do all those things. Doesn't cost you a cent, I promise, and it helps me out immensely. and you get notified when I put more junk like this up. So until next time, as always, don't just repair, restore. Thanks for watching. Catch you on next video.